arguably, I have two amazing gentlemen sitting in front of me who are the backbone of Zcash. So it's great having you guys. Um, I wanted to start with Tachyon. What's the core bottleneck that Project Tachyon's intended to solve?
Oh, well, this goes back to the construction that Zcash is based on. So Zcash is based on this old paper back from 2013 called Zero Cash. And in this paper, we sort of the way that we need to prevent you from double spending is every time you spend some money, there's all ZK snarks and zero knowledge proofs and stuff are involved, but you're forced to reveal this thing called a nullifier. And a nullifier is like we're going to say that word like 1,000 times today.
Gonna be sick of it.
Yeah, I'm very sick of it. I already kind of slur my words when I say it.
So maybe let's start with what is a nullifier?
A nullifier is a token that you are forced to reveal whenever you spend a particular some money. Like if you were in Bitcoin land, you would identify the money you're spending by the transaction hash of the previous transaction and the index into the output vector, if you're being technical. You're just identifying the money you're spending. And the network goes, okay, yeah, let me look in my list of transactions that haven't been spent yet. And goes, okay, that hasn't been spent. And then, some other rules are come into play. And then when that transaction is accepted, we mark it as spent. So that's how Bitcoin does it. In Zcash, we don't want to reveal which transaction is which transaction we're spending. So for all intents and purposes, we could be spending any of them. So how do we hide that? Well, using cryptography and tricks with ZK snarks, we are forced to reveal this token called a nullifier. And it looks just like random bytes. It's just like 32 random bytes. It's the output of a hash. And it is unlinkable. So you see it, you can't link it with any other nullifier you see, you can't figure out which nullifier corresponds to the money, to the transaction. And you, as a verifier, or the validators or the miners or whatever you want to call them in the network, they store the nullifier in a list. And then if a future transaction comes and tries to reveal the same nullifier again, then we know that you've double spent. But the problem with nullifiers in this original construction in Zero Cash, and this is how they laid it out, is that this list of nullifiers just keeps growing. And you can't go back and like delete one because we don't know which ones, you could be spending, you don't know the nullifiers that correspond to the notes, and it just, you can't delete them. Otherwise you might be allowing somebody to double spend and reveal that nullifier again. So you have to keep them around forever. And it scales with the number of transactions on the network, which obviously scales with the number of users and then some. So it's really a bad scaling problem. And we've known about it for since the beginning, I think. We thought it was a serious problem, and I think even before I started working on Zcash, we were thinking about it. I think Dara and Nate were actually at a meeting with Zuko and kind of trying to figure out what are we going to do about this nullifier. He was growing this nullifier set, and they realized early on, there's no way we're going to fix this problem before we launch Zcash, so we'll put it off. But they had some ideas, and that kind of years later turned into Tachyon, many years later. But it does stem from the original attempts to solve this problem.
So practically, if the set of nullifiers keeps growing, what does it look like to the user?
Well, I can tell you what it looks like to the network. So every validating node needs to store this list. And this list, like I said, it can't be pruned. So it's not just the history of the chain. So the history could grow, it could, in Solana, for example, is like terabytes of history. But if you run a validator in Solana, it's only like, 100 gigabytes, 200 gigabytes of state that you actually have to store. If, for example, Zcash were upgraded in the future to support more and more transactions per second, let's say 100, then the number of nullifiers that are added every day to this list, which again can't be pruned, is so large that the state growth grows by around a gigabyte a day, which is way more than it grows in other blockchains, way more. So increase. I mean, you have at some point you need to use, and you got to query the set arbitrary locations. It's not like you can just you can't. It's hard to horizontally scale this problem. So you have to have enterprise kit basically running validating nodes, which itself puts constraints on the rest of the network. Like I mean, if we can't just up the size of the number of transactions we can accept in a block, because we have to say, oh, well, that means we're going to have way more nullifiers if we do that. And that's going to increase the state growth problem even more. So now that's basically the problem we're trying to solve.
Yeah. There are also, like, in the current usage of Zcash with... My brain has almost come up with the correct sentence. So in the current usage of Zcash in, say, a mobile phone, like you're using Zashi or something, and you go offline for a while, and then your wallet comes back online. Well, one of the things that, from a user perspective, that has to happen is if you've received funds while you were offline, your wallet comes back on, it's going to find those funds. Now it needs to make sure that those funds are still spendable, because the user could have imported their their keys or whatever into two different. They might have two phones, or they might share a wallet with someone else. So again, to show correct balance, you need to determine not only that your funds that you've detected, but that the other wallet hasn't gone and spent them also while you were offline. And so from that perspective, you need to have access locally to the nullifier set to be able to check that that nothing's gone on there. And where this actually comes into play for usability in the current network is that the way that we do the sort of the light client protocol for making this feasible to do on phones means that if you find transactions out of order, like you find the more recent transactions first because that's just happened, you also have to fetch the relevant nullifiers for the transactions that weren't yours but that were recent and persist them locally on your device until you have scanned every single block prior to when you saw those nullifiers. Because it's an ordering problem. We know that a nullifier cannot occur prior to the note that it's derived from. Like that's a property that we can assume of the chain. But what that means is any nullifier you see from a later block could be a nullifier for a note that you actually receive in an earlier block. So you have to keep all those nullifiers around until you've checked all the early blocks to make sure that none of them contain any of your notes that you might have received while you're offline, and then you can discard that information. So it means that you either need to do sort of linear scanning, so scanning always from the earliest block you've not seen forwards, which means you don't have the reactiveness of like someone's just sent you a payment and you like see it immediately. You can't do that if you're doing linear scanning. You've got to wait until you've scanned like the day or week's worth of blocks until you're back online. But if you do the reactive one, well, now you've got a data storage problem because you have to cache those nullifiers for the blocks that you've scanned around that until you're sure that you don't need them anymore. There are other techniques that we've considered for like trying to solve this kind of problem with like oblivious lookups of things, for example, like having a service maintain a database of the nullifiers that you can query, but that database needs to be updated all the time because it's global state, and even trying to like break it into epochs and sets of things, it's still a difficult problem to do in terms of like making this a private query. When you have this global state that is just mutable by anyone on the network, by creating a spend and creating one of these nullifiers.
Yeah, so that's part of the. I guess that's a problem due to the fact that the wallets potentially don't know if their funds are spent during recovery.
Exactly.
But that assumes like a wallet model.
Yes.
Where you actually have to have recovery from the chain, and you don't know this stuff.
Yes,
and
like you noted, the point I made there was that it's a parallel wallet.
Right.
Now you could avoid this problem by not
supporting parallel wallets for one thing, and a lot of other things. Yeah. And that's sort of one of the trends with Tachyon, I think, is that we're rethinking a lot of the UX and a lot of the UX, but also what can the blockchain guarantee about the payment protocol and about some of these features, that stuff we've been doing with the blockchain because it's been cheap and simple, and it provides the UX we want, but it doesn't scale. And so we have to rethink the payment protocol and everything else to remove all these bottlenecks. So anywhere we see a bottleneck, we have to get rid of them. And not all of them are validator bottlenecks. Some of them are like wallet bottlenecks, and some of them are how do we support things like wallet recovery and things like that? Yeah, for sure.
Yeah. In your talk yesterday, Encrypted Money at Planetary Scale, you mentioned how the common progression with most protocols is that they go from making something usable, so just like finding product market fit, making it scale, and then only then do they like kind of think about privacy, right? But privacy isn't something you can add later. And Zcash's progression was much more like we started with privacy, and like the first sprout pool was basically super hard to use. You couldn't use it on a mobile phone. You had to like download this 10 GB thing on your computer, and you wouldn't expect regular people to use it.
Right.
And then with Sapling, it was somewhat usable on a mobile phone, and Orchard obviously made it. So you start with privacy, saying that privacy is possible, right? Like that was the first model where you had real cryptographic privacy.
Right, and the important thing that I wanted to highlight as part of that is that we really nailed the privacy at the beginning. Like in Sprout, we had, if you take shielded transactions in isolation, the on-chain privacy is as perfect as modulo quantum computers is as perfect as it gets. We have the zero-knowledge proofs, and literally the zero-knowledge proofs don't reveal anything about the coins that you're spending, and so quite a bit of the transaction data actually is either not revealed at all, even in encrypted form on the chain, or is encrypted and stored on chain, but could be vulnerable to a quantum computer in the future. But the point is that this strong property called ledger indistinguishability, it exists in the original Zcash. And so we've never actually upgraded the privacy of Zcash in a sense. We've only ever improved its security and its performance in future upgrades. So Sapling improved its performance. Orchard arguably improved its security by removing the trusted setup. That's sort of what I was getting at. Obviously, performance kind of comes hand in hand with usability, right? So it's a little blurred line there. We needed people to be able to use Zcash on their phones. Otherwise, that's
how people transact nowadays.
Right.
And it's no one's lugging around like a desktop with a nice processor to enable just going and buying a cup of coffee.
Yeah, and we've seen ever since we've had mobile wallets, like the explosion in usage of shielded transactions compared to before, and
the Zashi effect.
The Zashi effect, absolutely.
No, you need a wallet. You also need a good wallet, and you need like the UX of. Yeah, the UX of privacy is it's interesting and challenging because like it's very hard to sell privacy, like or it's the same thing as like when you have like back-end infrastructure in a service where like no one notices when it's working properly. You notice when something goes wrong, and I kind of feel like privacy has a similar kind of like marketability issue in that like if it's all going well, there's no problems. Like it's just your data is secure, your data is private. Like you like when something's being revealed, it's because you're choosing to reveal it. And then it's when something goes wrong, like someone who a company that claimed they had things that were private, and then suddenly they get hacked and data gets revealed, and that makes a lot of the news. And suddenly it's like, oh, maybe we should care about this, but actually like. Making the business case for baking privacy in at the beginning of a project it's a tough thing to sell in many industries, and it's the sort of thing where like, maybe you do need you sort of either need the scrappy startup like that we sort of had, we're full of old cypherpunks and people who just like sort of came through sort of the privacy focused mindset of that, or you need a company like Apple, which was able to establish itself as like with full vertical integration, and then is able to be like, cool, we can really market privacy now. And they've been doing a really good job of marketing privacy in the last few years, which they can do because they can actually guarantee, because they have full control over their entire stack, that that they can do so in a way that still maintains the usability that their existing user base has come to expect. Whereas we're on the other end of it, where like we want that same sort of guarantee of privacy through the full stack, where we can get it, and we would just be chasing the technological, pushing the technological edge of what Zcash supports to enable the usability that people need to actually use the privacy that we always had.
Right, with far fewer billions than Apple. Pretty
Yes.
much. Yeah.
I often thought about this, like if we switched the launch dates of Zcash and Bitcoin, like if you were to ask people if before cars were invented, they would just say they wanted faster horses, right? What they want is faster horses. But if you had privacy to begin with, if that was the first cryptocurrency, which Satoshi even wanted, right? He wanted Bitcoin to be private. He knew it just wasn't possible, I guess, back then. But a few cypherpunks, like including Zuko, were working on Zcash or Zero Cash, or thinking about it at least, since before Bitcoin. So it's like, I don't think a lot of people understand this, that Zcash sort of predates Bitcoin in a way. It just wasn't usable, and obviously wasn't invented yet, like because you needed the Bitcoin technology to build on top of. But on the other hand, Bitcoin didn't know the cryptographic, it didn't have the cryptographic privacy techniques that Zcash used. So, but anyway, if Zcash had been developed before Bitcoin, and then like Bitcoin came in like 2016 or whatever, so it switched to the launch dates of the two, like nobody would use Bitcoin. Like privacy would be normal at that point, right? It's like the first mover advantage sort of type thing. I do think like Bitcoin has a lot of mimetic potential just because it was the first to come to market. But like if you have a coin that's decentralized, that's private, 21 milli hard cap, right? All the properties of Bitcoin, but added encryption, and then somebody's offering you, just this coin that has a transparent ledger. Which one are you going to choose?
Right.
Right.
For sure. I mean, if Bitcoin did have those privacy guarantees, we wouldn't be having this conversation.
Right.
It's simple as that.
And also, like the Zero Cash authors and that ilk of people, I think maybe it was Zero Coin initially, and then the Zero Cash papers, but they originally were considering it as a amendment to Bitcoin, like an update to that. But the kind of change that would have been necessary to be able to add it to Bitcoin, and in particular with the technology that was available at the time, the cryptography that was available at the time, was such that the Bitcoin developers at the time, if I recall, were just like, it's not viable to be on Bitcoin. Take it somewhere else, try it somewhere else. And to be fair, at the time, that was a probably reasonable statement to make, because we launched Zcash when this technology was viable. Barely. It was beyond the bleeding edge of what needed to do to actually bring this into a public deployment of zero knowledge proofs with the kinds of constraints that we have in a blockchain setting. No one was doing that prior to then, because it was just, why would you do that?
Right.
I think there were some private deployments of ZKPs prior to that. Zcash is not the first usage of ZKPs. Zero knowledge proofs, have a long and storied history going back to Goldwasser, Michele, and I'm going to
late 80s.
Late 80s, GKR 80. I'm really bad at remembering these paper names. But the point is, it's a long history of academic research and improvement, and the techniques were known about when Bitcoin launched, as you said. But actually getting enough interest and enough funding and enough hype to some extent into ZKPs to be able to then drive the innovation and drive the engineering improvements that were necessary. It took time to do that, and Zcash did play a large part in sort of helping to kick that off and give it a platform to grow.
I think I remember. I'm thinking back to this comment that Satoshi posted on the forums where he was actually talking. It's hard to think. I think he said something to this effect. It's hard to think how zero knowledge proofs can be used for this case. So he's thinking, I think he knew enough about zero knowledge proofs; they existed, and so you can conceptualize. Okay, they could be used maybe for this. I'm pretty sure he knew. Yeah, I could prove I know I have some money that I can spend, but how do I prove I haven't spent it before? And that's where this, again, if there should be a bell above me that nullifier, and every time I say nullifier, it just dings. Yeah, the concept of a nullifier is essentially the solution to that problem that wasn't really obvious to him at the time.
Which is another one of those interesting things because the actual idea for that comes from a 1998 paper. It's credited in the Zcash protocol spec. I've forgotten the author names, but it's a 1998 paper on essentially like ways of doing anonymous, not anonymous, but no, I think it might have been anonymous like electronic transactions, and it basically had like if you squinted it, the Zcash shielded protocols are a refinement of the ideas from those papers. So there were people who were thinking about that, as early as the 90s. But again, it just takes time for it to percolate and come through, and it just wasn't at the right level of readiness for Bitcoin.
Yeah, there were other applications, but I think Zcash was the first, definitely encrypted project using zero knowledge proofs.
Oh, yes. Yeah.
Yeah, definitely. We productized it for the first time.
Productizing zero knowledge proofs, essentially.
And I think one of the Google co-founders, I forget which one, said something like that we had deployed ZK snarks faster than they were expecting that it could be done or would be done in practice. Like I've heard over the years, you guys really put ZK snarks out there like 3 years, maybe at least, ahead of schedule of academia. It was kind of surprising how fast that sort of was rolled out.
Yeah, and then the turnaround then to get Sapling out, which then was like another leap forward. Which because when Gross 16 was that was obviously 2016, but obviously that took time to mature and then be peer reviewed and make sure that was fine to use. But the turnaround then from dropping here's zero knowledge proofs to 2 years later here's the same thing but like 10 times faster and 90% less memory,
right?
And it's like it is
it was pretty fast, and it wasn't just taking what was
stressful.
Very stressful. I mean, at the same time when we were doing all these performance improvements, we were also fixing that bug in the original. I mean, in a sense, we actually didn't productize zero knowledge proofs. I mean, if you're being really picky about it, in the first launch of Zcash, because I had that Soundness bug in it.
Can you talk about that bug a little bit, just for people not aware?
Yeah. So in our first launch of Zcash, we used a ZK snark in it that had been around for a couple years, and we needed to do a trusted setup for it because it required a trusted setup. And so we came up with a multi-party computation to do it. That way, you had multiple people. In the case of the first launch, it was 6 people, and they could collaborate to construct the parameters that everyone needed to use in order to verify the proofs and create and verify proofs. And if one of the people involved in that ceremony was honest and destroyed the randomness that they had, which we called the toxic waste, if one of them did this, then the ceremony was safe, which is a good trust assumption. Generally, cryptographers are like, okay. If you have to do a trust assumption, a 1 out of n trust assumption is pretty reasonable. I mean, not if n is 6 usually, but but that's okay. I mean, it was better than the alternative because each person could have a different risk profile and do different things and be. You have to expect more collaboration for active malicious behavior in a ceremony like that when you have those kind of trust assumptions.
And also, again, for the technology that was being used at the time, the MPC itself was very expensive, just like the proving system was very expensive.
Yeah, for sure.
So that was the limitation why you could really undo 6 people.
Yeah, it could not scale to. We would not have been able to do that ceremony with more than 6 people. I mean, I'm surprised it even worked with 6 people because at the end of it, I mean, we had problems and hiccups and stuff throughout it, and somehow it worked, and we had like 1 shot to do it.
This is a nice video from ECC, I think, on YouTube, where there's like videos of you guys just like of Zuko and other people actually doing that process of the trusted setup.
Yeah,
That's
and
pretty
there's
cool.
the Radio Lab, is it?
There's a
Yeah.
Radio Lab episode about it.
Yeah. So so anyone who's interested in the history of that particular NPC, there's lots out there about
I mean, I could talk about that. That whole thing, that whole process was so stressful. Anyway, so the soundness bug that we're talking about, though, it was a flaw in the paper and the way it described the protocol, the snark. And one of the things when we launched Zcash is we went through and fixed a bunch of bugs. We went through and analyzed everything, found security holes and patched them and changed the design in many ways. But the one thing we didn't want to touch was the snark, because the academics put that through peer review, and we were told, don't fiddle with that. We need to launch this thing. If you go and fiddle with that, you're going to disappear into a black hole and we're going to run out of money. So just do that and don't mess with it. So we did exactly what this paper said. Well, the paper had a mistake in it and we didn't realize it. And so the MPC that was designed for the protocol produced some extra data in the middle of this protocol. And this extra data would allow you to create false proofs, and therefore you could counterfeit money. So the soundness of the scheme was completely broken if this data that was produced during the ceremony was public. That data wasn't actually used or shipped to users, but we had to make it public so that you could see what happened in the ceremony. So you could see that a ceremony even took place. You could see that the people that were involved actually contributed to whatever the parameters were at the end. In order to validate that, you needed what we call a transcript of the ceremony, which just logs all the messages that were sent between the participants during the ceremony. And in one of those messages contains, or at least one, probably maybe two, I don't forget, contains these values that allow you to forge proofs. And when we discovered this, I mean, it was late in the process of developing Sapling. So we had already started the trusted setup for Sapling. So we had already done all the optimizations and improvements, and we were doing audits, and everything was already well underway. And then right before we were supposed to do the rest of Sapling, we discovered this bug. And I'm glad we discovered it then, because we would have really been in trouble. Well, at the very least, we would have had to remediate the bug differently than the way we did it. The way we remediated it is that we folded the fix for the original launch into Sapling's release under a cover story that, there's a plausible reason that we would need to do it, which is that the original scheme was, it's strictly better, if you're being technical about it, to upgrade the cryptography of the original scheme.
And the thing is here, I did not know about this bug. I was part of the, I was there when we were building and deploying Sapling. I was part of I was learning a lot of cryptography as a result of it. That was sort of where I built my cryptographic chops. And I was part of these discussions where we were going what should we do with Sprout? Because it is quite a burden on the security arguments and things. And myself and my colleague Derek, we did not know about this vulnerability. It was that problematic that it was kept on a very tight guard. Only a couple of people knew about it. Sean was one of them. But yeah, so even in that environment, we were able to have we were just having, from our perspective, normal engineering discussions about what to do here. And we had some very good reasoned arguments for no, it makes sense to replace the proving system used for the original Sprout with the proving system being used for Sapling. And the strongest of those arguments was that it makes the maintainers' lives easier. We get to remove... as we evolve the Zcash protocol, we're accumulating technical debt. We're accumulating new cryptographic assumptions in various places, and being able to centralize on those and pare that down by dropping an older proving system to replace with a newer one, more succinct, but also that relied on the same overall trust assumptions, because it was still a trusted setup. It was still a R1CS-based scheme or whatever, but it was just a newer version. So, for all those reasons, it made sense to do that upgrade. And as a benefit, you'd be able to, Sprout got faster just by using the new proving system. It now only takes a gigabyte of memory the parameters are much smaller, and it's still nowhere near Sapling, but it was a good improvement. I remember thinking though, the real problem here, the reason why we probably won't do this is it's just going to take a bunch of time to do. And then the next, that was on a Friday, and the next Monday, Sean was so I just hacked this together over the weekend, and we go, classic Sean.
Well, obviously behind the scenes, I'm like, oh my god, if I don't do this, the project I worked on is gonna collapse. It was a crisis. So I hammered that out really fast. But the thing is, we actually were lucky. We were lucky in multiple ways. First off, that the code we had written for Sapling was so easy to adapt to incorporate Sprout, the original protocol.
Yeah, so the design of the Bellman proving system that Sean put together with learnings from what we from the usages of the existing proving systems that were out there, and then the way that was being used with Sapling meant that we could just all the core dependencies were there, and it was just writing essentially a new version of the original circuit, which ironically was easy to do because it was such a simple circuit. It was just some hashes and.
Yeah, the only hard part about writing the circuit, honestly, if I can remember really, it was just implementing SHA-256.
Yeah.
See, one of the constraints we did this trusted setup for Sapling, and the setup for Sapling was intended to be designed so that it could scale to a bunch of more participants than just 6, like in the original protocol.
Like scores, right? Like 100?
We ended up with, so it was a 2-round MPC. So you had an initial round that generated sort of the general structured parameters. You may have heard of the powers of tau. Which is just the set of parameters of data that anyone could then use for their own circuit. And then in the second round, you then took those and specialized them to the Sapling circuit. And we ended up with 90 people approximately in each of the 2 rounds, and you had to trust one of 90 in one person in each round overall to be secure.
Right. So I don't remember exactly off the top of my head why, but early in the Sapling design. Or early in the process of developing Sapling, we decided you have to figure out how big of a circuit the trusted setup is going to support in the second stage. So then that had to be fixed and decided at one point. And for whatever reason, I decided to make it as big as the current Sprout circuit, even though our Sapling circuit was to the 16, I think, or something like that.
It was much smaller, and that was part of the reason it was faster. And I think the reason at least that I remember you saying was that we were going to the effort of setting up these initial parameters. We wanted other teams to be able to use them.
Yeah.
And so having it go to, I think I thought you just rounded up to 2 to the 20 or whatever. You put it up a fair bit higher. Obviously, each time you raise this up a power of 2, it doubles the size of the data you need to do. So we could only go so far with the MPC that we had there, while still being able to make it viable for enough people to participate to have the extra security that we wanted. But yeah, there was an element of being able to make these parameters so that anyone who might have circuits larger than Sapling could still use them.
Yeah, and we were just lucky that. I settled on 2 to the 21 for that, which happened to be about as many constraints that Grot 16 needed for Sprout. But the problem is that there were some optimizations to SHA-256 that were implemented in libsnark that got it down to 25,000 constraints per compression function invocation. And so that was what took 2 days of engineering. Mad engineering. It was implementing SHA-256, and just to get the circuit constraints just below 2 to the 21. And once I was done, I was like, done. Here you go. Yeah, I know. So, yeah.
It's wild to me to see that this protocol has been shipping for literally now a decade, right? Almost a decade.
Yeah. We're 9 years now. So October 2016. So next year is the decade, but we're getting pretty close. And 2014, 2015 is when people started working on it. So yeah, I'd say it's a decade of work.
Yeah.
Yeah. I joined almost a decade ago, I think, probably. Getting close to that.
It was in 2015. Yeah.
Yeah. So.
Yeah, and it's cool to see more and more people now get excited about Tachyon and the recent developments, but having them go through the history, when I first went through the history, I was like, so there was Sprout, there was Sapling, there was Orchard, there's a bunch of other stuff in between that as well.
Yep.
But those are not, those are important, but not that important for the normal user,
right?
to understand. But thankfully with Zashi, it's super easy to use the latest tools now, so people can abstract away all that information anyway. But each one of these developments made Zcash scale more in a way, and Orchard made it completely trustless, so you don't even have to trust the 100 people ceremony, right? And so it's cool that there's some attention coming to the protocol after literally decades of shipping But I guess I don't know what you guys think of it. I'm sure like it's just fun to be like shipping code, right? How do you think of like the engineering problems in your head?
It is a lot of fun to see like a decade of work in a bunch of different areas. Like I said, there's been a bunch going on that we've done, and it's all in the last sort of year really started to like mesh and start to sort of like really come to fruition. Like you said, the Sprout to Sapling to Orchard, it was just doing a privacy protocol 3 times. And they each one had like improvements to various aspects of it, but like again, it's the privacy is hard to sell there. What do users experience from it, and is there much of a difference between Sapling and Orchard from a usability perspective? There are fun things we could get into discussing that, but sort of the chain of progress that's been made through there sort of meshes nicely with the increments that have been made on the mobile development side and enabling actions there, the progress towards enabling like hardware wallet support, like shielded hardware wallet support it's doable, but it's not trivial because the main issue we have is the curves that we use are not the Bitcoin curve. And everyone assumes it's all the HSM providers and things are generally working with either one of the NIST related curves or the Bitcoin curve. And getting custom stuff into there is like, it's a lot of work and a lot of engineering to get that in. And
is it generally harder to do like any sort of integration with shielded transactions? Because I remember when I was speaking with Josh and Zuko, they were like, Gemini was the only exchange that would accept shielded transactions, which is something that they had to like. There's some work that needed to be done to.
Yeah, what they're referring to, I think, there was that you can do shielded withdrawals from Gemini, and so that like most exchanges allow you to deposit shielded because like they might have a transparent address that they receive on. But the sender can send a shielded transaction that just unshields the amount that's going to the exchange. But the difference there is because at the end of the day, it's the sender of a transaction who creates the transaction and decides on its actual privacy properties, like what shielded protocol is being used, if any, or if it's using the transparent protocol. Like there's a bunch of things that affect privacy that are dictated by the sender. And so in this case here, it's like if an exchange doesn't have support for creating shielded outputs for a transaction, then they can't have they can't have like recipient address privacy, for instance, there. And so instead you then have to do sort of the weird, annoying hops that like we do in Zashi, where like you have a transparent address that you receive funds on, and then in Zashi we never spend directly from transparent. You always have to do a shielding step to bring it in. So it provides that provides the disconnect between what you receive and then where you then subsequently spend it. And that adds latency to the process, and it adds privacy problems to the process, because if you use the same transparent address in a bunch of places, they can all be linked together on chain, even if it's unlinked from your later spends. And even if you use multiple like rotating transparent addresses, they can still be linked just by a mistake in a wallet, or if your wallet is querying all those to the same Lightwallet server and they can tell that. All it takes is one slip up, and then those addresses are linked, and then transparent rotation hasn't really given you anything. Yeah. Whereas adding in, if the more things that are shielded, the better from that perspective. But it means that the teams that are creating those transactions have to add support for the custom output format that Zcash has. And Gemini were great. They worked with us to with ECC to be able to make that work for Sapling, and they've seen great success from there as a result of being able to support withdrawals, because it's perfectly fine within their business model. It's just it takes engineering work to integrate, because they have their own wallet stack, and it's just it's wallet work.
I want to talk a bit about the anonymity set in Zcash, because I see a lot of misconceptions about people basically thinking, oh, nobody uses shielded transactions, which obviously isn't true, and that leading them to the anonymity set basically being the number of people using Zcash, right? But in terms of shielded transactions, I think the anonymity set seems to grow monotonically with every single transaction. I know there's like technical details that I'm missing, but hopefully you can explain.
Yeah, that's fair. I think.
Yeah. It's
What made you?
the answer here is always it's complicated.
Yeah, anonymity sets are very complicated.
Yeah. So like the broad all generalizations are false, right? We'll start with that generalization. In broad strokes, the shielded protocols work by when you create a note, you reveal a note commitment, and then when you spend that note, you reveal a nullifier. That ding. And those two things are unlinked. So ostensibly, every time a commitment is added to the tree, that's a new note that could be a source of funds for a later spend. Now, obviously, there's an arrow, like that immediately means you can see there's an arrow of time thing there, which is that if you have a particular point in the tree, a nullifier that occurred earlier in that point cannot have been the result of a note that was generated later, because time doesn't run in reverse. And so that's where this like monotonically growing aspect comes from, which is that the later in history that your note is spent, the more prior history there is where it could potentially have been created. And so the desire when you're spending a transaction is to pick a point in the lifetime of the shielded pool that is as recent as possible, while still accounting for like chain reorgs and stuff, because you want reliability as well. But then it starts to get, then you start to get into sort of the messy heuristics of, well, okay, now you have to think about, okay, you have a subset of those notes where like some amount of value is revealed. And so there's papers from 2018, 2019, like there's some papers that have been looked at, they've been looking at the Zcash privacy, and what they're normally looking at is like, okay, movements of funds into the pool, movements of funds out of the pool, and doing linking there. And that's kind of the obvious, like, if you're using a shielded pool as a pass-through, you're really not getting the privacy that it can provide. You get your privacy from storing funds in the shielded pool, so that your actions, even if your actions exit the pool, those actions aren't as correlatable as amount go in, amount go out, or timing of amounts going in and out. So in broad strokes, yes, the anonymity set grows over time, and you want to pick something that's later, and the set size is of that. Then you have the messiness of like the interaction with transparent, and I will note that those papers that looked at like looking into what you could glean from these, none of them were able to glean things about purely shielded transactions. So if you use a purely shielded transaction, sticking within a single pool, you don't have any problems there. That academics have been able to find thus far. Which then brings up the next thing: multiple pools.
Right. Yeah.
Which is where you have several anonymity sets, because you have within a single shielded pool, you're generating notes. But then that's the sapling pool. We also have the orchard pool, which is also generating notes. So it is a independent anonymity set.
In a sense, you can think of them as different protocols that just happen to have bridges.
With each other. It's sort of within the Zcash protocol, within a Zcash transaction.
Right, and that's why I think when anonymity sets are talked about, and in your question you were mentioning, what's the difference between? I think you were alluding to what's the difference between a protocol that has shielded transactions, where the anonymity set's growing, and every time I make a transaction, it's like way better than the anonymity set of the previous ones. Whereas in another protocol, it might be that the anonymity set for any particular transaction is the same, no matter how many transactions there have been.
Right.
But what if everybody had to use that? Small anonymity set on all their transactions. How do you compare that to a protocol where not everybody needs to do that? Well, I personally think of the transparent pool as just being another currency, or basically another currency that's bridged over to, or another, I don't know how you describe it, but another currency that's bridged over to the shielded pools via the Zcash blockchain, essentially. And it doesn't matter how many transactions are taking place in the transparent pool. There could be 1 million billion transactions taking place on there. but the anonymity set is still really, really strong for each individual transaction in the shielded pool. But if you have a protocol which just has a really crappy anonymity set for every transaction, but there's no transparent transactions, there is no anonymity, really. I mean, there's a qualitative difference there that you can play mind games to try to argue that, oh, it's not private by default in Zcash. It really doesn't matter how many people are using the transparent pool. It doesn't matter. It doesn't affect the privacy of the shielded users' funds at all.
The relevant point for like usage when it comes to the shielded pool is it's less about an on-chain privacy thing and more like it's at the point where you're getting really into like network analytics and things, because if only a small group of people are generating transactions with shielded components, well, then if you just see an arbitrary transaction, it's going to, with high probability, it's going to be one of that small group of people. So, if that small group of people is 10 and there are like 1,000 or a million people using Zcash and only 10 people are doing that, well, that's enough that you can go and knock on someone's door and ask them, did they actually make that transaction? That becomes a problem. It is good to have more activity in the shielded pool from the perspective of from out of band concerns for this. Like if we think of like you have the chain itself, which is the indelible record of everything that's happened, and we care about privacy on that very strongly because that's visible to everyone. Everyone has access to the chain because that's how it works. And so anyone can go and analyze the entire history of it and like retroactively break privacy if there's a weakness that was unknown at that time in history, but later on is discovered to be a problem. And that's one of the reasons, like I mentioned earlier, I think lots of conversations have bled together this week. So I don't know if I mentioned it earlier now or yesterday. But like I mentioned earlier, sorry, my brain just stalled out.
I forget what you were talking about.
Yeah. I'm going to have to start.
It's okay. We can just we'll remember. It's fine.
Yeah,
I think one thing I had in my stack, if I unwind my stack, I forget why I was going to mention this since we're all brain farting anyway. Proportionality of your anonymity set versus concrete anonymity sets. So you can have a big anonymity set, or you can have a huge shielded pool, and that's good. The more people are involved in the pool, that's good. Now, if you make transactions where you only leverage a portion of that anonymity set, then you start talking about set intersection attacks. Anytime you have already eliminated for your adversary that you are a huge portion of the potential people that your adversary is trying to determine as you, if you've eliminated like 99% of the other users and you've only said, I might be this person, that person, that person, and that person, you have totally screwed your anonymity up because all it takes is one bit of information, really, aside from that, either from another transaction you do or anything, the time you're awake, any other detail that your adversary can get, and they can completely identify you. So you need both a huge anonymity set, so you need lots of people using shielded transactions, of course, but you also need shielded transactions to blind yourself among everyone in that anonymity pool, or almost as many people as you can, which goes into what you were talking about earlier.
And I've remembered where my brain farted and where I cut off. So like I was saying earlier, that like we sort of started with privacy as the base thing that we wanted to get right and get that in from the beginning, and then make the usability improvements on top of it. It was important that privacy be preserved as much as possible for the on-chain data. But then, in addition to that, you have like the network layer data, network observability. So for instance, there is like, with the light client protocols, if you are a light client server operator, like you have a point in the network that you can see a bunch of data, and by looking at patterns of like who requests what transactions from you, you can observe a bunch of information that you can use to reconstruct who is potentially interacting with whom, which entities, which users are interested in the same transactions. Now that still doesn't break the on-chain privacy. Like you can't decrypt them. Because viewing keys, we very strongly ensure that discourage patterns where viewing keys are ever given out to external services, because that gives out a viewing capability to decrypt those transactions. But yeah, so it's you still can't see like the sender address, recipient address, or amount, but as a light wallet, you can potentially see those links. And so making improvements to the network layer and how the wallets interact there is also important. And so that's, for example, where the Zcash ecosystem, and specifically through ZCG, funded the Tor project to develop Arty, being a Rust client, Rust library for implementing Tor. And now that exists, like Zashi, we've now started integrating that, and we're starting to use it for more and more of the network connections that Zashi makes to provide a level of unlinkability and make it that much harder for network entities to be able to make these kinds of correlations. And then you can also people can also run their own infrastructure, so that run their own Lightwallet D, so that they can see what they're doing, but that's fine because they're inside their own trust boundary. But that's less usable for your average user. So this gets to that sort of like tension there between we want something to be as usable as possible, but when you start adding on-chain privacy, great, we've got that pretty settled. Once you start bringing in the network level effects and things, it all adds latency and friction and user experience downsides, which is difficult to balance with. People expect I can just tap for pay and then it's just done right there. And so getting that right is an art as much as a science. Mm-hmm. And it takes a lot of time and care to work towards.
Yes, well, to me, the lengths to which the Zcash team has gone to really maximize the privacy in the protocol, and it's crazy to me that it's even a debate. It's not a debate amongst serious cryptographers, but amongst some people that Zcash versus some other coins who might be using decoys or mixers. And going back to your point about even if you try using Zcash as you just go in the shielded pool and come out, which doesn't really work, right? For maximum privacy. For maximum privacy, you want to stay as long as possible in the shielded pool. And that I think is a good argument for not only store of value in private money, but also private money as a medium of exchange, right? It works as both because now you're storing value for longer periods of time, increasing your anonymity, and also transacting.
Yeah, you're the less you leave the shielded pool, the better, and the less you leave the shielded ecosystem within that, the better.
And the more detached. When you leave the shielded pool, you can leave the shielded pool. It's fine. It's actually totally okay under the right conditions. Yeah. And one of the conditions that's important is that the amount of money you have and the other transactions you're doing are detached from your economic activity at any given time. So one example where that doesn't work is if you're using it as a pass-through, then it is attached. Then your wealth, my wealth just came from the transparent pool and then went back out. That is not that's an example of it being attached.
Yeah,
right?
It's the linkability problem of people there are academics who are very good at statistical analysis and way better than any individual user is going to be. No one is going to be able to adjust their the amounts they're sending in and out of these things to hide their
you're not. I guess the way people put it is you're not going to beat the AI.
Yeah.
I mean, I don't like using that argument quite as much, but still.
They are very good at pattern recognition, yes. Yeah. Automated pattern recognition, yeah.
In a way, I think Zcash is a long position on AI. If you believe in the progress of AI, AI is just going to come and automate all these surveillance tools, right? For corporations, for big governments, just make it super easy for pattern recognition. And so...
you don't want to leave patterns.
The least data you can provide, the better. And that is something we again, privacy is a complex story here, because even though the on-chain privacy is the best we can get it with our protocols, we still we reveal the arity of a transaction, for example. So like the number of physical inputs and outputs on a transaction is
The number
there.
that could have been used.
Again,
it's very complicated.
Yeah, it's an upper limit on how many notes could have been used. Well, that doesn't actually give you much, and that's why we're comfortable revealing that information, because you don't know if it's 3 1-zec notes or 3 1,000-zec notes. Those are indistinguishable. But there are so there are patterns that you can have, and that's why it's also important for wallet developers to be aware of the kinds of transactions that they're creating and try and reduce any distinguishing features that they can where they can. There's other techniques that people use, like if your wallet has funds in, say, both Sapling and Orchard, then some wallets will try and maybe take transactions that pay from both pools simultaneously if they don't have enough to pay from one, to avoid pool crossing and going and revealing partial values. But that itself then means that you can see that you're using both Sapling and Orchard at the same time. So it's a different kind of pattern. And ideally we would just have as few patterns as possible, but in the extreme ideal, our spherical cow in a vacuum would be every transaction fills up an entire block on its own, and that is very unscalable.
Right.
So again, it's one of those engineering trade-offs where we are very conscious of the kinds of things that can be leaked and the patterns that can be revealed, and we do our best to minimize those where we can, and focus on ensuring that anything that's going to be sticking long-term in chain is, things that wallets can't control or have or users can't have any action over are as tamped down as possible.
That reminds me of something in Tachyon, which is that we can't, you can know the possible arity of inputs and outputs in Orchard, for example, or Sapling or whatever. In Tachyon, it's a little bit more obscured in that you can't tell how many commitments / nullifiers are revealed are actually commitments, or
because they could be either.
Right. So there's little privacy improvements that happen. We don't really. It's not what we're going for. It's not the goal.
Just indirectly with Tachyon.
Yeah, it's a nice improvement from that perspective. So
it's one that's hard to quantify though. There's a lot of privacy improvements where you can say it's better probably, but it's really hard to think of an example of where it actually helps, like an attacker scenario, basically. And that's one of the reasons why when we prove that when we create a protocol like Zcash, we're trying to use a security notion like ledger indistinguishability, because ledger indistinguishability basically means I can't tell the difference if I'm an adversary. I can't tell the difference between one transaction and the other in terms of its effect on the ledger. That captures a broad range, and in fact, probably almost every possible attacker scenario that you can think of. And when you do, this is how cryptographers think. For example, when we do security analysis of like an encryption scheme or something, we look and say, can the adversary distinguish between ciphertexts that they have the influence over the plain text or whatever? These kinds of things. That kind of broad, comprehensive analysis of the security of a scheme is how we think of privacy in Zcash. And so, although we sometimes can't really tell what attacks it helps, it really does help us feel safe because, 3 or 4 years down the line, 10 years down the line, somebody has an academic paper where they say, aha, that was a problem. And we want to avoid those kind of issues. And a lot of other projects in this space, they're just plugging leaks, and more leaks are springing up, and you can't plug leaks with Band-Aids. You really can't.
It is so much simpler and less tiring to not have to think about all the ways that something can go wrong. It's like just you put in the extra bit of energy and thought at the time you design it, and then I can just forget about it for a while.
That's sort of what kind of goes into a point you were making earlier about building privacy in the foundation of the protocol, because if you try to bolt it on at the top of the stack and you try to add it, it's not really an additive thing. You can't undo the leaks that take place in the layers below or in the things that you're replacing or trying to. You have to build it into not just the foundation of the protocol, but the whole entire stack of the protocol, all the way up from the core protocol to the user experience, to the wallets, to everything.
Yeah, it's the vertical integration, and so like I mentioned earlier about like Apple having a similar like privacy story and similar vertical integration. I think in Zcash, like we've had for a long time like integration from like the very low layer protocol logic and specifications through to like a decent depth, but I kind of feel like, particularly, like, not that I'm biased, but like I work on Zashi, so well, I work on the back end that powers a bunch of stuff in Zcash, including Zashi, and it has been very nice to be sort of in the interactions at the top levels of UX, because thinking about privacy from the entire layer,
Right.
yeah, lets you spot these like things where like cross-layer interactions that might be negative, where or we've had plenty of places, not even in the privacy protocol, just in the regular protocol, where like one part of a layer is making one assumption about what the other side will do, the other side implemented by someone else makes a different assumption, and the interaction of those assumptions causes a problem. And if it's just a logic bug, well, sure, that's going to affect a few users. Like the blast radius of a logic bug can be like smaller here, potentially, depending on the kind of logic bug. There can be some very bad logic bugs, but like in most cases, like the effect of a problem that is like it prevents you from spending for a while, like that can be relatively limited. Whereas like a privacy problem, like it's like once it happens, you can't undo it. So yeah, having focus on as much of the stack as possible, and what I'm finding now in the last couple of years is direct experience with those top level stacks, not just talking with other people who are doing them, but actually like thinking through like how is this UX going to impact it myself, or talking to the people at ECC who are building those UXs and going, hey, have you thought about this thing? And
right, yeah, you have like people working on Zashi, like Strad, are cryptographers and privacy experts, and they're thinking adversarially about the UX in ways where other products in the space, they just build the protocol. They might have privacy features in them, but then they ship it off to the next team in the org that builds the wallet or whatever, and they don't think about what it means for capabilities and privacy and all these nuances to protocol design and the user experience that has to do with privacy, because you can. It's really the wallet that guarantees your privacy. The wallet determines what chain you use. The wallet determines what protocol you use. The wallet determines how you use the protocol. And the wallet has more things than just the protocol. Obviously, it's the network. It's the
wallet promises to not post your transactions on Payspin.
Right. Exactly. So, yeah, you need a comprehensive privacy plan in a project, and if you try to add that later on in the process, you're going to have like half-assed privacy, or you're going to have really bad usability because you haven't really thought about it from the beginning.
Right. I'm guessing it's super useful that the entire privacy stack is being built at ECC, kind of like from the base layer to the wallet. It's like what Elon always wants, right? He wants his engineers and designers to be in the same room. And, so there's like that feedback going on because the engineers are telling him, this is how it needs to be. And like from a first principles lens, like why, just like physics, right? Like how things work. It's the same way, like cryptographically, why it needs to be a certain way. And then you go to the top layer and like maybe in other projects, because the teams work differently, at different times, different speeds. They're not really in sync that much with the privacy aspect. And so maybe they're butchering the privacy a little bit.
The way I think about it is that it's like what you need is like privacy expertise throughout the entire stack. And like, yes, for a long time it was like, a lot of the development was happening within ECC. That has since like broadened. There's a bunch of other groups and orgs, and like Sean, you're off on your own now, so you're external to ECC. But there's a wide range of people who are involved at various layers in the stack, and with that comes like no one's got a full picture, and no one can keep it all in their head. People tell me I'm able to. I really don't believe so. But you do need people. You need people who are thinking about the full stack and have exposure or access to people involved with the full stack to be able to like make that meaningful change. To jump across to a different domain, but one that also I care about, memory safety on platforms. There's a lot that you can do as like a software engineer or a compiler engineer or working on these to try and improve memory safety. But if the hardware below you is like doing weird things with pointers or whatever, then you're going to have problems. Or same with constant time code. Like if your CPU is going to optimistically turn like, oh, you multiply by 0, I'm going to make that faster, and suddenly you've got a key leak bug. You need people who are thinking the entire way through the stack, all the way down to the silicon, in those cases, to be able to protect against that. And not to harp on, we've pointed Apple again, but the recent like memory tagging extension stuff that they were in, it was a nice example of like a full stack all the way through to the silicon, where they were thinking about like how can we. What can we do at different layers to provide the right protections to make it performant enough that we can add this stuff into the silicon that no one's tried adding into the silicon before because it was just deemed too expensive. So we have the same thing at Zcash. Like the circuits are our silicon. That's the stuff that we bake in at the base layer, providing the core privacy. And that we've had to think all the way through the stack of where can we make the performance trade-offs that enable, that at the higher layers that enable us to pay performance at the lower layers to provide the privacy that then the higher layers can build on top of. And having a slice through the entire stack is what enables that. And so having people who like have to read a bunch of code and read a bunch of specifications to be able to do that is important.
Yeah. What are the implications going to be for wallets once Tachyon is live? Because if you're calling it encrypted money at planetary scale, it's gonna mean at least like 8 billion people using it, right? And you're hoping for more people to be born, because I think the world's underpopulated. There should be like trillions of people across the galaxy. So hopefully we can use Zcash one day with that many people, with Tachyon enable that.
Well, it removes the bottlenecks that we know about in the cryptography, so that I guess my goal is really to put us on the same playing field as all the other blockchains. They don't have a privacy story. They're trying to bolt one on. But because they don't have a privacy story, they have a lot of flexibility to scale. Our privacy story is a really strict one, where we have this, again, ledger indistinguishability property where you can't tell the difference between transactions. That's a huge negative for scale, because being able to tell the difference between transactions is how you scale in a lot of different ways. Like if you know what state a transaction's modifying, you can process it completely independently and in parallel with every other transaction taking place. For example, and there's many other reasons that being able to distinguish between transactions is important. And so if we want to keep that strong property, what does it mean for what does it mean for the scalability architecture? Well, it means that we need to go through and change the cryptography in many different ways to remove these bottlenecks that appear because of the privacy. So Tachyon removes those bottlenecks so that we have the same constraints like bandwidth and latency constraints in our project. And that's a little bit easier to solve because, in my opinion, we can just go and take the best option that other people have been working on, but only we have the head start of having the privacy already. We have the protocol that's working, whereas they're trying to take all their users and take all their infrastructure and make it private, which is really, really hard because it's not designed that way. There's a tension between the scale and the privacy that is really hard to fix.
What would be next after Tachyon? I know you said that you expect, at least in mainnet, Tachyon to be live within next year.
Yeah.
So like within a year. What would be, as we were talking about on the way here, like perhaps other bottlenecks springing from Tachyon, or maybe other unsolved bottlenecks?
Well, there probably will be. We've talked about this before. There's always problems that spring up once you fix other problems, and it's never ending. I'm sure there will be things we didn't expect would be problems, especially if we change the UX. We have to change the UX to scale. We know that what we're doing right now just doesn't work. That doesn't scale. We're getting a good UX out of it, I think, but it's just not practical going forward. So we have to rethink the UX, and if we have to rethink the UX, there's going to be some things that we're going to say, oh, we can just hand wave it away. We'll fix it with that. We'll fix it with that. One of the problems that I see that we don't have a solution for it yet, but I think we'll work on it, and it's a general problem, is one of incentives. So there's this trend in Tachyon and probably other problems that we're going to be facing in Zcash, where we're going to say, okay, the user, this is too painful for the user, and it's too painful for the validators. So we're going to add intermediaries and other entities that have to run infrastructure, especially in Tachyon. And that infrastructure takes the burden from the user or from the validators or from the finalizers or whatever you call them, the roles and the different roles in the system, and does certain operations, whether it be computations, creating proofs, or doing whatever. Maybe we're able to do that, like in Tachyon, without compromising user privacy. But who's going to run that infrastructure? How are we going to incentivize them to do it? It's a good story because we can make it so that if it's not a privacy risk, people aren't incentivized to co-opt it to harm users. So that's really good. But we still need an incentive model, and we haven't really figured that one out. Scaling the incentives, I think that's going to be one of the hard challenges. We haven't figured that one out yet. That one's in the same camp as some of the other problems that we're facing when it comes to bandwidth, latency, incentives. That's
And then another aspect of this that's going to come up is like the again, coming from the change in the user flow and in the wallet flow, is how do we ensure that funds are sufficiently like secure and recoverable and whatnot? Because like right now, you can you can set up your wallet, you can back up some like mnemonic phrase or key material or whatever, and then come back in. If you drop your phone in the hypothetical mud puddle, then you can go back to your steel backup and pull back in, and you're good to go. This doesn't work in a Tachyon workflow. So what does it look like for users where you need like efficient, reliable backups? Now there's additional infrastructure needed for that as well. And we do have we see like companies like Google and Apple and that who are trying to do this stuff at scale, and even they have they have their limitations in terms of what they can provide. And of course, we want to make sure it's private as well. So the story there is one that needs to be sort of figured out as part of the integration work of this into wallets, to enable the to ensure that we do not want to deploy something that has a high like user loss of funds risk. And a requirement for users to manage their funds in this way, is it
requires
adds
the infrastructure.
Exactly.
Yeah, and we there's a lot of problems with this. I'm having my own brain fart a little bit. I wanted to make a point. Let me see if I can remember what it was. I can't remember what it was. Sorry, you're gonna have to cut that. But I don't know. Whatever. I was gonna make a point based on that, but whatever.
So sort of on that vein, you've got the backup situation in terms of reliable funds. Jump in if you remember.
I remember my point. So, so we're gonna have to possibly change the way the protocol works so that it scales, but we're moving problems that don't scale from one platform to another. Like we're moving it off chain to another system, and it still doesn't scale, but at least it's not on the blockchain. That could be a stopgap for now, and then we can throw different solutions at that problem that work differently or have different competing user experiences that try to experiment to see, how do we get a good combination of requirements and user experiences.
It also isolates the problem a bit better. So like you saw in the big rise in like the horribly named ZKVMs, which don't actually use ZK, but they use the same cryptographic techniques for like verifiable computations. And just like the way the incentive structure is sort of laid out in the ecosystem, there was huge amounts of effort that went into figuring out how to efficiently prove and verify for these particular kinds of very large circuits. And I imagine that a similar thing would happen once you start having these services who are trying to be incentivized to be as efficient as possible. You will start to get like focused development on both just at an engineering level, making that stuff work better. And like there's so many things that you can just do that we don't even do in the current protocol. That once you have a particular kind of regular computation centralized in like one part of the stack. People can go to town on optimizing it in that way, and academics have a nice juicy target to build papers from.
Well, and also that plays into the incentives. Like if you have incentives to build infrastructure, you have incentive, especially if it's for an isolated task. You also have incentives to run the infrastructure well, or to design the protocol so that it's more efficient or whatever. So I think that compounds the benefits of breaking it all into separate pieces.
Yeah, it means individuals don't have to think about the entire Zcash stack at once. They can sort of focus on like the area that they are running or they are contributing to.
It's possible that it does introduce risks too, because now you have multiple systems and you have to think of the privacy implications of how they interact.
Yep. Privacy is complicated.
Yeah.
Do you think Tachyon will spin up a whole new set of blockchains? There's like this concept of weightless blockchains that I think comes from Tachyon.
I've heard that term before. So there's this thing called a succinct blockchain, which is just an idea, and it's essentially these things called recursive proofs. You can make it so that you have a recursive proof that demonstrates that an entire blockchain was valid, and you only need to look at the proof in the latest state of the chain, basically. And it's really amazing that you can do that. And we actually use those tools in Tachyon. So that's a succinct blockchain. What we're doing in Tachyon is we're also making it so that state part can go away. So if you're a validator, you don't need that in order to make updates to the state. It can be continually pruned. So in that sense, there is something new here. So yeah, I guess the answer is yes. This is huge. I mean, what we know right now with Tachyon's design is that you can get a protocol that has the same features as Zcash today, including this very strong privacy, with marginal proof size or marginal transaction sizes and verification time that rival that of Bitcoin. And that's amazing, because at that point you start to wonder, what is the point of Bitcoin and protocols like that if you have access to the cryptography that does this? This cryptography is not just going to go away. It's going to be there forever. So this stuff is changing the game for sure.
Yeah, and I also will. The concept of a purely weightless blockchain is also probably a misnomer, because even in the case of like the succinct blockchains, what was succinct was the verification of state, but there was still a chain of data that you had to like pick figure out where your data was on it. And even in the case where like you're minimizing the amount of state that you have to keep around in the global chain, there's still in these offloading helpers that we're pushing stuff to, they have to maintain some amount of backlog of state that is going to be linear in the size of in the amount of usage over the period that they maintain, to enable people to keep up and keep using the chain. So even when you're using recursive proofs to do these like very succinct weightless style systems, like that has benefits at the core full node verification layer. But the weight doesn't go away; it's just shifted elsewhere, and you still have to manage that weight existing at least for some period of time, depending on how you build the UX around it. This isn't a magic hammer that makes every nail go away, but it is a tool that really changes it's a shift in what we can do and what we can build versus what we could do previously.
So you made a recent edit to update to your GitHub, added a little icon, I guess, something called Ragu. What's Ragu?
That's right. You're right. So Ragu is this part of the code for Tachyon. It's this library that sits at the core of it that does most of the heavy lifting for Tachyon. And so I've been working on it for months now, and it's going to be ramping up a lot, and I'm releasing the code soon, and getting it audited and things like that. And it basically just does the recursive proofs, and it provides the features that we need in Tachyon, and the performance requirement, meeting the performance requirements we have in order to build Tachyon. The rest of the application layers for the protocol that gets integrated in. So it's step one on the ladder for the code. And so but it is an isolated library. So it provides the ability to create recursive proofs using, among other things, elliptic curve cycles, including the pasta curves, hence the, hence the reference, haha. So yeah, that's basically Ragu. So
I'm curious about Tachyon, but starting with you, Strat, what's the next 12 months look like for you in terms of shipping, updates?
I was just saying, part of that network upgrade is like it's a big complex upgrade, and we didn't want to have the complexity of applying it to the existing legacy Zcashd codebase. None of us are really willing C++ coders, and like it incurs a lot of cost on what is really a very small overall development group across the various organizations, and in particular, at ECC, who we're the main maintainers, have been the main maintainers. We have so many different things we're trying to do. Like trying to also maintain this is just not viable. So the ecosystem is transitioning to Zebra, which is the implementation built and maintained by the Zcash Foundation, fully in Rust. We're transitioning to that being the primary implementation. So that's a big part of my next 12 months, and really it's the next 3, ideally, but it's going to bleed through. Is building the replacements for that. So Zebra is the replacement for the full node, but the Zcashd node was not just a full node, it was also a wallet, and a full node wallet used by exchanges and mining pools and all sorts of other, if you were just deploying Zcashd and you had a wallet, that's what was powering it. And so there are people using it with hundreds of thousands of users, et cetera, for managing their funds, and we need a replacement for that. So the other main thing that I'm working on at the moment is Zale, which is a full node wallet designed to work with, backed by a single full node and have a single view of the network from that. And so it's designed to be an always on, you run it as a service, and then you make RPC queries to it, as distinct from like Zashi, which is it's on when you're using it and then it's off for a bit, and so that's a big thing. We hit the first alpha 2 weeks ago, and so we're in the sort of the alpha phase now. We're done with pre-alpha. We're into the alpha phase of building out all the functionality that we want to exist in Zale. And then after that, we'll have the beta for stabilizing the features, getting that through, and then getting to the point where it's production ready. People can start migrating off Zcashd and onto this. So those 2 timelines of Zcashd deprecation, building Zale to fill that in, and the NU7 being able to activate it, are all sort of like interlinked and together, because we need Zcashd to be off the network when NU7 activates. And to get off Zcashd, then we need Zale to exist and Zebra to be ready and all that. So there's a lot of moving parts there that we're working on. And then there's also Zashi, where so all the feature development that's happening from the Zashi team, when there are things that myself and my fellow core engineers at ECC need to provide as a backend, like that's additional work that has to happen in there as well. And there's going to be all sorts of fun things happening in the next 12 months with Zashi, I'm sure.
Yeah, Zashi is so great. I'm so grateful that Zashi exists. I've tried the other wallets. They have more capabilities. Sure, I know Zashi's going to have more capabilities soon as well. I would really like the rotating transparent addresses.
Yeah, there's ongoing work on that. Yes.
Cool, awesome. And also Josh was telling me about Zashi Vault, other features like that. So super exciting. What about you, Sean? What do the next 12 months look like for you?
Well, the next 12 months are Tachyon for me. And what does that mean? Well, it means shipping into mainnet the protocol that allows you to create Tachyon transactions, but not necessarily a comprehensive story on the wallet side. That's something that happens in parallel. It probably happens after Tachyon activates in mainnet, and it's going to require a lot of UX design and a lot more infrastructure being built. And so it's a process, and of course everybody has to upgrade to using Tachyon over time. So it's definitely, but the first big hurdle is getting the protocol solid and getting it audited and getting it merged into the protocol, into Zcash. And it's definitely doable in 12 months. I mean, it is ambitious. When we did Sapling, we did it in about, I don't know, like...
It's about a year and a half, I think.
Yeah, it was about 18 months.
Yeah, it was like mid to late 2017 when you start, like, we're really getting into it.
Yeah, so 18 months to do Sapling was ambitious, and somehow we pulled it off. And, you know, it wasn't like an existential threat like Sprout was. We were about to run out of money when we launched Zcash. We had to launch it when we did. Yeah. Sapling was less of an urgent thing, modulo the counterfeiting bug or whatever. But so it's possible. But of course, when you look historically, with Sapling, we had everybody on board with Sapling. We had alignment, and we also had everyone working on it at the same time. And that's different now. Things have changed. Although, I mean, we pulled Orchard off, but of course it took like 2.5 years or something like that. I forget exactly. 2 years.
It was a bit under 2 years of development on Orchard, from like where we started it through to getting on, because of course it was, you know, the initial it was the initial Halo work in August, September 2019 that kicked it off. And then it was really late 2019, I think December or so, we started like getting in, and it was out in May 2021. So even then, that was actually, that was closer to a year and a half even.
Yeah, so it's definitely possible to do this, especially if we don't have wallets that have to use the thing. Yeah. I mean, we want this stuff done, but...
Yeah, the issue there was more that like when we launched Orchard, we didn't have wallet support in there. Now, actually, if you compare that to Sapling really was like a 2.5 year project, because it was 18 months to deploy the protocol piece, and then another year spent working on the mobile SDK. We launched the Android SDK about a year after a year after Sapling launched. So at that point, it was possible to use it in a wallet. The same thing, unfortunately, ended up happening with Orchard, where the Orchard wallet rollout ended up being taking longer. But like, it's going to be a similar thing here, where like the protocol itself is like a year of concerted effort to get that out, and then the wallet work on top of it that enables is going to
I mean, it's an ambitious timeline for Tachyon for sure. It's not impossible, and we've shown that we've been able to do things like this in the past in this amount of time. Like I said, in the past, things were a little easier because we had everyone doing just one thing. Now we have many teams, like Shield Labs is doing Crosslink, ECC's got Zashi, and everything else they're doing is all A and stuff. So the important unlock to make sure that something like Tachyon can ship in a year, which is ambitious, is that the network upgrades that everyone's working on should not interact with each other, or at the very least they should have synergy, and we shouldn't be trying to step over each other and trying to get things merged and deployed and activated in mainnet. So I've tried, for one thing, to make it so that Tachyon doesn't depend on, require, or interfere with features that other people are building. So I'm spending a lot of time on that, and I have spent a lot of time making sure that that's the case. It helps reduce competitive pressure amongst the teams, but also it's just good strategy for shipping quickly. We need to maintain that. In the last several years, or I guess the last 5 years, depending on how you think about it, we've had this tendency to think of network upgrades as this real like sequential thing where it's not like hopping on a train. It's what are we getting into this upgrade, and then the upgrade takes as long as it takes until we get it shipped, and then everybody waits for it to be shipped before we talk about what goes in the next one, or that kind of thinking. And we need to just do upgrades as soon as we have stuff done, and we need to. That's basically how we should be. We should do release trains. So.
And the interesting thing there is we had those same conversations like 5-6 years ago. We've wanted to do that kind of thing for a long time, and then you hit the reality of like actually trying to get something out and like the complexities you find and getting things through, and also the probably a bit of like tunnel blindness of like once you're in the process of trying to get something out, like you almost just want to be done with it and get it through, and to that extent, actually the sharding is probably going to help somewhat because we have there are more teams doing individual things, and you still need the crosstalk. You still need people to agree on what is going to be a cohesive Zcash protocol, like as a whole. And so we have entities like the zip editors who sit at a point where they're like keeping track of everything that is going on and doing reviews and things there. We have various like meetings like the Arborist calls where the various teams get together and sort of like keep an eye on report back on what they're doing, what they're struggling with, and things they've discovered and how things are going. And I'm interested to see us evolve those in ways that will sort of stick and enable us to get these network upgrades out in a more in ways that don't step on each other. We've been working towards that. I think it's going to be easier to make that stick now that we've got more people contributing these, and to some extent, I'm actually kind of glad here that you Sean are external on this, because you've got experience of doing network upgrades with the team internally. And that's something that I think having someone who's been in that process now be external but contributing there is something that we really haven't had thus far.
It's an unlock for sure. Definitely.
Yeah, and similarly with we've got Nate and Zuko and Matt at Shielded Labs on the Crosslink side, who are in a similar position where they've been inside on this side for the initial network upgrade series, and now they're out doing it from externally. I think that's going to like significantly help for like post NU7. I think NU7 is maybe we've definitely had some issues getting things through. Although, as I said, part of that issue has been the tension of the old world dying, the old Zcash world dying, the new world struggling to be born, of the sort of decoupled Z3 stack of the Zebra layer for the foundation, Xano for your chain indexing, and Zale for your wallet stuff. And once we get to that point, again, more decoupling of the pieces, it's going to be easier for people to make the changes they need to.
Yeah. I think it's really important that we work on ambitious things in Zcash. Ambitious timelines. Everything worth doing is worth doing on ambitious timelines, I think. And it's really nice to have this like sort of Damocles over your head because your credibility. You're going to look like a clown to the Zcash community to be like, you said that you were going to get this done in a year and you didn't. You wake up every day and you go, God, I don't want to look like an idiot. I really want to get this out, and in the past, that's really motivated me to work really hard to finish something. Now, maybe I don't want to speculate, but maybe it does hit a delay, and I'm like, but it has to hurt, it has to be painful, and that's a forcing function for making good effort, and we owe that to the Zec holders, and we owe that to our mission actually. So we need to be ambitious.
I love that. And now recently also started working with Tall from Penumbra. And are hiring one more engineer.
At least one.
Yeah. Do you have any advice? Maybe a potential candidate would be listening to this. So if you have any advice for them to apply.
One piece of advice that I'll tell you, and that I've heard a lot from a lot of people who were interested in working, but they're like, I'm not a genius. I'm not I don't do that much crypto. I don't know that much stuff. I'm not a genius, and although I knew crypto quite a bit before I did this, it wasn't on the level that some of the other people, even in Zcash, were doing. You don't need to be a genius to work on Tachyon. You really don't. You can learn all this stuff from other people working on Tachyon. It's totally possible. You just need to have a good mindset and good values, and be motivated, and also be a good Rust programmer. Please, be a good Rust programmer.
That is probably the must-have. 20 years of Rust experience on a yes, and Rust is 10 years old now.
Yeah, but no, it's totally doable, and think better of yourself, and you can do it.
Yes,
you can do it.
Yes, willing and tolerant Haskell programmers also accepted.
That's right, and we know that actually works out very well.
It does work out very well. My colleague Chris is his previous job was Haskell programming. He has reluctantly accepted that Rust is useful. He keeps trying to get me to learn Haskell, and one day I will actually do that for him.
But he's a practical Haskeller. He doesn't try to. He tries to coax you in, but he's not mean about it. He doesn't.
Yeah, he accepts that there are benefits to the approach that we're taking here.
Yeah, he's one of those people that. Speaking of backbone of Zcash, people like him are like unsung heroes, really.
Yeah, plus he's also a blacksmith. So
yeah, that's awesome.
It's fun.
My final question for you gentlemen is, what got you into Zcash in the first place?
So I was already very interested in Bitcoin and playing with Bitcoin for years, and I knew that eventually somebody was going to make a private version of it or make Bitcoin into private version, whatever. It was just a matter of time before the cryptography was mature enough, and there had been some discoveries. There was this year in I think 2012 or 2013 where there were these, or maybe it was a little earlier, these massive advances in homomorphic encryption and snarks and all this other stuff happening all at the same time, and so it really looked promising that eventually it'd be practical and there'd be a private version of Bitcoin, and that's what I wanted from Bitcoin. It wasn't enough that it was very cool that Bitcoin was sovereign money and it was decentralized and this and that and stuff like that. It was really cool stuff, but it needs privacy. Otherwise, to me, it's just useless. I see it as a tool of surveillance more than anything. And so I knew it was going to happen eventually. When the Zerocash paper came out, I was a little groupie, so I hung out on there was like a Zerocash subreddit or something. I hung out on there, and everyone would post every 2 months and go, are they still building Zerocash? What's going on? I never could have dreamed I would have been involved in the project. I had been working on, in my free time, the goofy pseudo privacy version of Bitcoin, my own thing. And then when the Zerocash paper dropped, I'm like, okay, well, there's no way all these Greek symbols, I'm going to learn all that. I'm just going to wait till they ship this. I'm going to buy it, But I fell into the laps of the company, I guess. And, I just knew the right people, and I was lucky. And I was ambitious and working really hard to learn this stuff. And so I just managed to land on the team and learn from really, really great cryptographers at the company and the founding scientists who are more than eager to sit down, and when I ask them questions explain, how does a Boolean constraint work? I was like, how do you constrain it 0 or 1? That's what? Something I would think now is well, you don't know how a Boolean constraint works, but yeah, I was like, oh, that's really cool. Multiply just two numbers together and whatever. So yeah, I really loved the goal of Zerocash. I think it was important. I loved the cryptography and the math involved. I had already been studying it, so it just was the perfect fit for me, and I'm so glad that I get to work on this stuff. It is a dream come true.
So in my case, I got into privacy as the sphere, but I was originally in network privacy. So I'd always been interested in cryptography, but I never had the chance to study it, and it never quite worked out. But I was doing physics and mathematics and chemistry and that sort of thing. And then through whatever path that it ended up being, I don't remember all the details, but I ended up working in Tor and I2P and in that kind of space. And through that, I got to know online Darian Hopwood and Zuko through Tahoe LAFS, LAFS, the Least Authority File System. And the largest, we got to know each other because the largest public deployment of Tahoe LAFS was inside the I2P network. We were running it in there for file storage. And I then went to Real World Crypto 2014, which was actually the conference where Matt Green presented the Zerocash paper. And I was sitting there in a balaclava, effectively. I was there pseudonymously. And I got to know Zuko and who were at the conference there, so got talking to them, still just as Strat. Fast forward to 2015, and I'm finishing up my PhD thesis, And Zuko messages me and goes, "Hey, would you be interested in like working a couple of hours a week on Tachyon AFS for like, doing some things? Oh, and by the way, I've got a super secret project I can't tell you about, but you might be interested in." I go, "Okay, that sounds great, but like, this is September 2015. I've got to finish my thesis. Come back in like come back in a month. I'll be done by then." And then every like few weeks he'd message me, "Have you finished the thesis? Have you finished the thesis? Have you finished the thesis?" Eventually gets to January, he goes, I want to hop on a call." And so we hop on a call and he tells me about Zcash. And I go, "Wait, shit, this stuff's possible?" And that, because that was when I learned about zero knowledge proofs. And I was like, wait, hold on a minute. This stuff's amazing. I want to get in on this. Unfortunately, I had just taken another job to do some app development because my funding had run out, and so I needed something. So I was doing 20 hours a week, so I couldn't go full time. That's okay. I'll take the rest of your full time. And so I was then working 40 hours of work a week on this other project and I was still trying to finish my thesis.
Ridiculous.
So that was a bit of a ridiculous following 6 weeks until I could sort of get all that off. And so then I was working at ECC for sort of the February 2016 through till about the July, and at the point, and we ended up launching in October. And so at that point, it was like, okay, no, we need you full time now. So I had to put the other stuff aside and join the company full time. And then just carried on through. And that sort of was, I'd had the interest in cryptography through the privacy, and I'd sort of picked up cryptography stuff from doing the privacy things, but I'd actually mostly gotten into it from a usability perspective because I was looking at these tools, network privacy tools, and going, they're not very usable, and I didn't know how to make them better. I don't think I would really succeed on that, but my thinking sort of started from like, how do we make privacy usable? And so that's sort of been the through line that I've sort of ended up, helping out all the way through the stack, while also being able to like build up my cryptography chops within the Zcash project. I remember giving a talk where I had to explain how zero knowledge proofs work, and so the 3 weeks prior to that, I was querying Sean and and one of the founding scientists, going, "So can you explain to me how zero knowledge proofs work?" And that was just so much fun to be able to just like figure out like, yeah, this shit is possible. Like, and it actually works. It's just mind blowing. And so I've carried through that line on usable privacy all the way through, and it's nice to sort of see it like a bunch of other people getting on board with it now.
Mind blowing moon math.
Yeah.
Gentlemen, it's been great speaking to you, and I really appreciate both of you and all you've done for Zcash, making this thing usable and now scalable, and obviously scalable throughout the process as well. But really appreciate you guys.
Yeah,
Thanks
thanks.
for your time.
Thanks.